So, welcome to this lecture 19, which is cables continued. We talked last time why do we need underground cables, what is the need, because the world population is increasing like anything, and the space is same, the land is same. In fact, the water is increasing, the sea levels are going up because of the greenhouse effect, and so we need to go for alternative to the overhead transmission line, and the only alternative possible is cables, underground cables. Now, what is the capacitance of single core cable? I have drawn a figure here. The conductor radius is r, the inside radius of the whole cable is capital R, and as you know, in mathematics you have to consider a point at distance x, and dx is the incremental radius. Now, this is a metallic sheath. Of course, there is a armoring and all those things for protection. This is full of dielectric with permittivity value K. Some people write epsilon also, but to type epsilon or write epsilon there is a problem. So, I have preferred using K. Of course, similar good luck is not available to permeability, there we use only mu, there is no alternative to mu there. Here there is an alternative to epsilon. Now, if you plot the electric stress in a single core cable, unfortunately it is not uniform. It varies as you move from conductor radius to the inner radius of the cable, and it is maximum at the conductor radius or at the surface of the conductor, and it is G max. And as you go towards the outer part of the cable through dielectric, it reduces, and finally you get Z min. That means, dielectric is stressed to 1/5 of the breakdown value, because we have to worry about G min, sorry G max, and G min is very small. Q is the charge in coulombs per meter of axial length, V is the potential of conductor. Those of you who have done field theory, all these things should be very easy for you. In any case, you must have done cables earlier. Now, as I said, G was defined as electric field intensity gradient, and you know the equation G is equal to Q upon 2 pi k x, x is the radial distance to a point from the center of the conductor, Q is the charge we have just now defined, K also I have told you, and gradient is always given by voltage per meter. Now, if you want V, it will be integral of r to r G dx. Substitute the value of G and you get the answer log r by r when you substitute the limits, lower limit. This integrals you must have done 100 times or 1000 times in past so many years. The capacitance between core and sheath is given by C Q by V. Those things you can substitute. I am just directly giving the result 2 pi k 0 k r. K 0 is the permittivity of the free space, that is 8.85 into 10 to the power minus 12 farads per meter. K r is relative permittivity, this r, this is farads per meter. You substitute this, G is also equal to, if you manipulate here, you will get V x ln by r by r. The only variable is x. So, if you want G max, the minimum value of x is r, so you get G max. If you want maximum value, then R, if you want minimum then capital R, and the ratio of G max by G min is naturally R by R. Now, this should be as close to 1 as possible, and for that what we do? Anybody remembers, or all of you have forgotten? We need grading of cables. So, grading of cables is of course an important topic. I do not want to do it because you already done it. My aim is only to refresh your memory and not to go in more details. Now, R is fixed, capital R, because the total dimension of cable is fixed. What you do inside is your problem. For example, the government has fixed your fellowship, maybe 5,000, maybe 6,000, maybe 8,000, maybe 10,000, depending on which fellowship you are getting. Is it MNES, is it high value fellowship, is it Government of India, or whatever, is it CSIR. But how do you spend? I do not think anybody has any right to tell you what you should do with your fellowship. It is up to you. Whatever minimum base load, as I call it, fellowship, the fees, mess dues, electricity, water, books, copies, and then whatever is remaining, it is up to you whether you send home, which is very rare, small percentage, or whatever you can do. So, similarly, that R can be adjusted. What should be small r, etc., etc. That is up to you, and it is the job of a designer. Power system design for a given voltage is always fixed, and this inverse E is there exists. This you must have been told by your mathematics teacher. For a given V, there exists a small r which minimizes G max. So, this is the condition for design of a cable, because we do not want to stress it to any higher degree, to avoid any possible reason for breakdown. That is, we want to maximize this quantity. Why you want to maximize this quantity? Because if you want to minimize G max, you have to maximize the denominator, so that G max will be min. So, it is a min max problem, optimization technique. You are minimizing the maximum value of G. So, this should be maximum. If you carry out this maximization problem, naturally the only variable is R. So, d by dr of this put it equal to 0, solve it, the answer is this. That means R by R should be E. Any natural logarithm of something is 1 means that something is E, and this E is 2.71882. So, as we move towards away from conductor, it is under stressed. That is what we have been talking for last 5 minutes, that G max to G min. Therefore, more uniform stress distribution is required. Otherwise, you are not using the gradient, the insulation, the dielectric to full extent. It is like hiring 1 hour cab for 1 hour and using only for 2 minutes. You are unnecessarily paying. Across the dielectric to minimize minimum amount of insulation required for a given RV, and this is the topic of grading of cables. So, grading of cables is the difference between G max and G min should be minimized. You can't make it 0. There are so many things which you can't make 0. You can't make your expenses 0. You can't make your profits or fellowship or whatever infinity. That is impossible. It is only theoretical. So that less insulation or dielectric is required, so that I pay less money. Ultimately, everything boils down to cost. So, capacitance, there are only 2 types of grading in literature. capacitive grading and intersheath grading, which you must have learnt in your undergraduate. Intersheath is better than capacitance grading. What is the power factor in heating in cables? The best book for reading cables is VD, I have already told you, and old timers can read Cotton or H. Cotton or otherwise not old timer, he is still live and still books are still coming. Classic, when I say Loney, that is a classic, the book which went for a century and more. So, Cotton's books my teachers have also read. Barber and Cotton is the latest edition. Wadhwa has given a chapter, of course, on cables. Yeah, that way Soni Gupta Bhatnagar has also given, Mehta has also given. So many books are there. I don't think Algad gives anything on cables. Even Stevenson is not giving anything. We have only given few pages as an appendix in that brown book only. Now, this is the equation for resistance. Rho 2 pi L log of R by R ohms. Rho is resistivity, everybody knows, and capacitance, capacitive current supply is omega CV. C is the cable capacitance. Okay. If you plot a phasor diagram, you will find that the charging current is leading voltage almost by 90 degrees. Though the figure does not show that effect, but practically speaking phi is almost 90 degree and delta is very small. All right, phi is 90 degrees, where cosine phi is a cable power factor. Cosine phi is also equal to cosine pi by 2 delta, that is a trigonometry you must have done in your 9th class or 8th class, I do not know. So, cosine of pi by 2 minus something is sine of same angle, that everybody knows, and when delta is so small, the sine of small angle is angle itself, and this is also tangent. So, power factor is delta, and V by Ri over omega CV. Or 1 over omega C Ri, V gets cancelled. This is a power factor for a cable. Dielectric loss, this is a very important loss in cables. Breakdown of a cable can cause or can be caused due to thermal reasons. What these losses, why we do not like any loss? Because not only that your efficiency goes down, but it creates or generates or produces, whichever word you want to use, heat, and anything that produces heat is bad, whether it is argument, whether it is a parliament, whether it is a electrical engineering or mechanical engineering, but heat you cannot avoid. So, losses generates heat, so temperature rise takes place, and temperature rise I have been telling you MATR, maximum allowable temperature rise. If you go beyond that, there may be blood pressure problem, there may be even heart attack. So, we do not want to break any hearts. So, or there can be mechanical causes or there can be electrical causes. What are different losses? These are the things which can be asked in interviews, and you should know about this. Core loss, dielectric loss, sheath loss. Fortunately, sheath loss is very small. Dielectric loss we have just talked about it, caused by dielectric absorption and polarization, and it is very small up to 33 kV. What is the equivalent circuit of a cable? It is a leakage resistance in parallel with cable capacitance. This is an equivalent circuit for a cable. And please remember, there is no pi network here, there is no T network here, nothing is there. There is only one network and it is in parallel. Now, the circuit is so small that whether it is in parallel or series, it hardly matters. But since the book says it is in parallel, let us also say it is in parallel. So, some of you are capable of arguing, sir, how it is parallel? To me, it looks series. Okay. So, dielectric loss is a loss in the equivalent leakage R. This R, like a transformer. You must have done an equivalent circuit of a transformer. 6 parameters: primary, secondary, and the magnetizing branch, which is in the middle, but taken into one end for simplification. Every person in the world wants simplification, easy life. So, to make our life easy, they have shifted that middle branch to one end. Now, dielectric loss is V I cosine delta, E I cosine phi, sin phi, and this is equal to E I delta also. I is equal to V omega c. So, dielectric loss is V square omega c delta. If you want to expand omega into 2 pi f, this is the equation for dielectric loss. Those of you join a cable company like Gloucester, or like there is one in Faridabad, Hindustan cable company. So, then you will need this knowledge more. (33 kV) the rated current,
dielectric loss is less than
1%, and 400 kV it is 15%. Sheath loss is roughly 0, 2% of the core loss. Now, ionization is another process which takes place and it creates problem. And this question is almost always asked in cable: void formation. Why they take place and how do you avoid it? Yes, the effect is a chemical reaction resulting in a gradual breakdown of the dielectric. Now, it can be even a manufacturing fault. Do not think that you have created void. While manufacturing, and if it is in India, people are careless, maybe voids have been formed. But even if manufacturing is perfect, it is made in England or made in US, void can still be formed while in use because of contraction and expansion. Chief cause of deterioration of a cable is dielectric, and dielectric is a must. Now, DC, everything we are now going DC except generation. In fact, solar is again a DC. MHD is again a DC. So, I should not say that generation is also only AC. There is a DC generation as well, may not be in bulk, but we are again moving towards dispersed system from the vertical integrated power system, dispersed and distributed system. Now, you can read more about it in our new book also. There is a, if you have seen that, we have ordered a copy to library. You can read the first chapter, which is very useful for interviews. So, DC cables also are there. It is not a fiction, it is reality, and they are available up to plus minus 600 kV. Losses are definitely less than AC. Whenever you are asked what are the advantages of anything DC over AC, there is no skin effect. Dielectric losses are also small, sheath losses are smaller, and what is cross bonded cable? Anybody? I want to test your knowledge. Anybody remembers what is a cross bonded cables? People have done PhDs on cross bonded cable. One of the students did with me, Pramod Kumar. See his thesis in electrical department, library, departmental library. Cross bonded cable is like your transposition, corresponding thing in transmission line, overhead transmission line is transposition. So, here it is cross bonded. I think with this we will finish the cable topic today, and Tuesday we will start insulators. Now, what is insulators? Why you should have insulators? Because the transmission line wires are live. So, on poles or on towers, depending on the kV, the voltage, we have the insulators, and there are mainly three types of insulators: pin type, strain type, and suspension type. It is mainly suspension which is used, and the strain type is used for a special purpose, wherever there is a change in direction, wherever there is a dead end, wherever there is a river, wherever there is a crossing. So, we use the same suspension instead of vertical, we make it horizontal, and that is called strain type insulator. Now, the pin type is of course there up to 33 kV, but beyond we go for suspension type, and that is modular in approach. The higher the voltage, more can be added, and again there is a problem of uniform distribution of voltage there. So, if you want to avoid that problem, what you do? You can make the cross arm length so long, but then it looks very ugly, and the first thing, where is the space? We are always worried about space, right of way. So, that option is ruled out in the present day world. So, we go for a different option, and we will talk about it. That is called grading of insulators again, like grading of cables, and there is a guard ring used, or there are different types of insulators can be used, but they are not practical, because again the line insulator, that is insulator closest to the conductor, is stressed maximum, and others are as you go progressively towards the cross arm, they are stressed less. We will see all those things. Of course, we have done it, so I will not take much of our time in insulators, but small amount of insulators. Then I intend to do sag and tension again in one lecture, or and tension. You have not done, so we will do it, so that those of you who have not done it, they should know. Yeah, it is very important. And then we will go for insulation and not insulation. Load flow is next semester. Then we go for AGC, we go for HVDC and distribution. Facts, if time permits, why not? But we are roughly 1 month left, so we stop today.